The purpose of this video is to help you kind of get a game plan for conversion, for problem solving when you have percentages that are given in the problem and need to be used as conversion factors. So I'm just going to give just a made up example here. If we have something that is 10% by mass hydrogen, what does that mean, and how can we write an equality with it? And then what we're going to learn in class, those of you that have class with me will find that when we have an equality, we can then use it as a conversion factor. So anytime you have a percent, you're going to write your equality as parts, in this case 10 parts out of 100. So if your percent is 5%, then you'll have 5 parts out of 100. So maybe this is water is 10% by mass hydrogen. That's actually not a true statement, but we're just going to use this as an example on how to set up a conversion factor. So what we're talking about is hydrogen as the part, and the whole is water. So whatever your percent is, set that as parts equal to 100 parts of the whole. And then this is where you have to be a little creative, like what am I going to use here as a unit? And you could use a variety of things, and you'll probably be able to use what the problem gives you as a guide and make a good choice. And this is grams probably, or kilograms, because it's 10% by mass. So I could use grams here, but I could also write a similar equality and I could use kilograms. It really won't matter what you use as long as you use the same thing. So let's look at a true homework problem that has been posted with a student question. So one of your homework problems, and I don't even know exactly which problem it is, but it states that water is 11.2% by mass hydrogen. So we're going to do exactly the same thing. We're going to use that information to write a equality. So our equality would be 11.2 parts out of 100. I'm not sure that shows up. 11.2 parts out of 100. Hydrogen is the part, water is the whole thing, and again I get to choose whether I want to use grams or kilograms. I'm just going to arbitrarily decide to use grams, and we're just going to go with that. All three of these pieces are important because this problem asks about kilograms of water and grams of hydrogen. So I need to keep track of what's hydrogen and what's water. That's kind of why this one's a little tricky. So let me write the question in a new way. How many kilograms of water would contain 6 grams of hydrogen? And I'm going to use dimensional analysis to get from the given, what we're given, to what we're trying to find. This is the question. What are we trying? The desired unit. What are we trying to find? So grams of hydrogen need to be converted to kilograms of water. So what I'm going to do first is go up here and use the equality I've written, and I'm going to write it not as an equality, but as a conversion factor. Grams of hydrogen go in the denominator because I want to cancel them. Grams of water go on top, and I'm going to write them down exactly as they appear in the equality. 100 grams of water to 11.2 grams of hydrogen. Grams of hydrogen cancel, and if I were to calculate this, 6 times 100 divided by 11.2, that would tell me how many grams of water contain 6 grams of hydrogen. That's not what I want to know. I want to keep going and convert grams of water to kilograms of water. And this is a metric to metric conversion, so we know 1 kilogram contains 1,000 grams. And we multiply 6 by 100 and divide by 11.2. and divide by 1,000. That should get you started on a problem that looks like this. Yours might be worded slightly different, or maybe doesn't use 6 grams, but another mass. Let's look at one more. I believe this is probably maybe in the same problem, or toward the end of the homework, where you have another percent that some blueberry fiber cakes contain 51% dietary fiber. So again, what can we do with that piece of information? We can write an equality with it. 51 parts out of 100 are fiber. So what's the whole thing? The whole thing is blueberry cakes. I guess these might be muffins or something. Okay, so what does that mean? We need to use for a unit. Again, we can kind of be creative here. What unit makes sense? I can see that I'm going to be working with grams at some point, so I'm just going to go ahead and use grams. The problem also tells me that a package is 6 ounces and it contains 6 cakes. So right away I know in my mind that 1 cake then must be 1 ounce. How many grams of fiber are in each cake? So I'm going to write the question a different way. How many grams of fiber are found in 1 cake? And that's where I'm going to start. 1 cake is where I'm starting the dimensional analysis. And I'm obviously going to have to get rid of cake and convert it to something, and I think I'll convert it to ounces. 1 cake contains 1 ounce of cake. I know that just by the statement here that each package is 6 ounces and there's 6 cakes. So that's just kind of something that I did in my head. Now what? I need to convert cakes eventually to fiber, and I have this equality here that will be helpful. I just don't know if I can use it yet. So maybe what I need to do is convert ounces of cake to grams. But then I look on page 24 and I don't see a conversion that allows me to do that. Instead, I find that I can convert ounces to pounds. 1 pound of cake is 16 ounces. And then I'm going to continue. Again, I've got to cancel what's here always and try to move myself closer to my goal. Now I can convert pounds of cake to grams of cake. This equality is found on page 24. 1 pound is equal to 454 grams. So you kind of have to be creative in your problem solving. It may not be one step in your dimensional analysis, but several. Pounds of cake cancels, and I have grams of cake. I'm getting very close to what I'd like to know. I'm going to continue this below, but it would just be an extension here of my problem. Grams of cake can be now I'm ready to use this equality that came from my percent. Grams of cake can be converted to grams of fiber. I know the equality is 51 grams of fiber in every 100 grams of cake, and notice that's exactly what I was looking for. So this is fairly complicated in terms of the number of conversion factors that we had to use. Individually, they're pretty easy to locate. It's just linking them together in the right way makes this work. So mathematically, I'm going to take 1 times 1 times 1 times 454 times 51. And then I'm going to divide by 16 and divide by 100 to get the final answer.